Okay, we are going to start with question number 3 of your practical list now. Okay, question number 3 says, write an assembly language program to simulate add operation on two user entered numbers. Okay, so we need a instruction to read the user entered number first. Okay, so what will this instruction do? It will read an integer from the user and it will put it in the accumulator register. Now to create this instruction, please see I have used the name read. However, in your guidelines, the name is input and the opcode given is F800. Okay, so when you create this instruction, please feel free to use the name input and the given opcode. I'll show you how to create this instruction. So we say modify machine instruction, and I have already made this instruction here. So I'll go over this from here. Please see, I have used the name read here. Okay, and what fields are we going to use here? Please see. Since the IO instructions and the register reference instructions do not require any memory access, we already know this, that we do not need to put any address in the 12 bits of the instruction. Okay. We can rather just have a 16-bit opcode. Okay. So I'll put the opcode as OP2 here. Okay. And give this instruction the opcode F800. Okay. And now what do we want to do? We want to choose a IO instruction. I'll say IO and we'll say new, and then name this instruction whatever you want to. I have named it as input an integer into the accumulator register. Okay. Now what we need to specify is what do we wish to get entered from the user. I want to read an integer into the accumulator register, and what should be the direction? The direction should be input. Okay. If we had to make the opposite instruction, that is the write instruction, as you can see here, then what we would have done, I have named it write. Your practical list tells you to name it as out, and it has given the opcode as F400. So let me take the opcode as F400. And what should be the fields that we're going to use here? Again, let's use OP2 here. Okay. So this will be the reverse instruction. As you can see, this is again an IO instruction. And the only thing which is different in these two instructions is the read and the write is that the direction here is output. The type is again going to be the same, that is the integer, and the buffer is again going to be the same, that is the accumulator. Okay, so this is the write instruction. Let's say okay. Okay, now we need an instruction to add the numbers. Okay, how will this instruction work? Let's make this instruction in C. So again, I go to modify machine instruction, and in here we see add. Okay, now please see add is a memory reference instruction. Okay, that means what am I saying? I'm saying that whatever I am giving in the address part, okay, whatever operand is stored at this address, please take that operand, okay, and add it with whatever is in the AC. Okay, this is the meaning of the add micro instruction. Okay, so what do we do? we already have the instruction in the instruction register by virtue of our fetch cycle. Okay. We take the 12 bits from the instruction register, which will contain what? Which will contain this address part. Okay. So you can see that for any memory reference instruction, the fields have to be OP and ADDR, where OP is 4 bits long is required, and ADDR is also 12 bits long and it is required. Okay. Now, you can again, as I said, you can choose the opcode given to you in the practical list of yours. So you can choose it to be accordingly. My machine is old, so I'm just putting in some, using the opcodes that I've already given. Okay, now we need to go, we take this address from the instruction register. You can see that, yeah, the 12 bits, the former 12 bits. Okay, we pick those from the instruction register and put it into the memory address register. Then go to the main memory at that address, whatever is present there. What will that be? That will be the operand. We put it into the MDR, and then we add that to the accumulator and put the sum back to the accumulator. This is what is to be done in a add machine instruction. These are the micro instructions for the add machine instruction. Okay, so what kind of a transfer would this be? This would be transfer R to R. We are just transferring the contents from the instruction register to the memory address register. So you can see that. So the source is IR and the source start bit is 4 and the destination register is MAR and its start bit is 0. Now, why is the source start bit 4? Because we don't wish to put the opcode into the address register. What we need to put is the address part, okay, which is the last 12 bits. Okay, so we say that the source register is IR, destination is MAR, and from the IR now, this time we are saying the source start bit is 4 and please transfer 12 bits, okay, into the MAR and start putting those from bit number 0 in the MAR. Okay, so this is how we transfer the operand, the address of the operand from the IR to MAR. And then we go to the main memory. This is again a read operation that we saw earlier. You can see that. Okay, so read main memory. The data should be put into the memory data register and the address is in the MAR. Okay, and then we need to, whatever we've got, the operand we've got in MDR, we need to add it to AC. So what kind of a micro do I need to make for this? We will make a arithmetic micro for this, right? So you can see that it is very simple. So how to make this? Please see, this is the name. What do we want to do? We want to add what? Accumulator with the data register and put back where? In the accumulator. Now, if there is an overflow, please set the halt bit that we have already made, right? Say okay. And we say okay, right? Now, there are two more instructions here. One is store. This is the same as the STA instruction you can see here. So what this does is STA. This is, you can see this is the same as STA. That means store AC into whatever is the address or the variable name written after it. So what is the variable? What is a variable, by the way? Variable is just a name given to an address, right? What happens when you say int A in some high-level language, such as, let's say, C, C++, Python, the system allocates 2 bytes of memory in the RAM and names it A. Okay, so this is actually what this is actually your address only, right? So when I say add sum, I can put sum here, or I can actually give just the exact address of the sum here. That means where this variable is stored. This instruction will work just the same. Similarly, you can see 2 instructions here, store sum and load sum. These are the 2 memory reference instructions that we're going to see next. So store sum is the same as store AC into the sum. Okay, so whatever is in the accumulator right now, we are saying that please go and store it here. Now, what is the sum? Sum is we are declaring a variable sum. Okay, how to declare a variable in CPUSIM. So whatever you want to name the variable, I've named it sum. You put the name of the variable, follow it with a colon. So colon. So this is a syntax, right? And then we write dot data. Okay, dot data is again a keyword. It is the syntax. And then I say 2, 0. Okay, what this means is that please reserve 2 bytes of memory for this data item named sum, and put in an initial value of 0 in that data item. That means you can call it a variable. Okay. So what we are saying here is store sum. That means store the value of AC in sum. We just saw that, see what is happening here. We have read an integer and then we say add sum. That means that particular integer is now being added to AC and the result is again being put into the AC. Okay. And then I'm saying store sum. That means the result which is in AC, the sum so far, it should be stored at this variable sum. Okay. So how to make this machine instruction store or STA as per your guidelines? Let's see. So again, I go to modify machine instruction and I say store. Okay. And I give it the, now this is a machine reference instruction, right? So I have to give it the fields as OP ADDR. Okay. Now, and you can give the whatever is the opcode required to be given as per your practical list. Now, what do we need to do here? See, we, as usual, as in the previous instructions, memory reference instructions, we simply transfer the address, okay, where the contents of the AC are to be stored into the MAR, okay, and the contents of the AC into the data register, and then put these contents of the data register into the main memory at this address, which we have just now put in the MAR. Okay, so this is a register to register transfer that you've already seen. This is again a simple register to register transfer. You can see that, right? So AC to MDR. So the source register is AC and the destination register is AC. The starting bit of both the registers is 0 and the number of bits to be transferred is 16. And now this time we are writing into the main memory. So we go to the memory access and this time please see all other parameters remain the same. So that means I'm saying the name of the the memory is main and the data should be taken from the memory data register and the address is in MAR. But the direction this time is right. The direction this time should be right. And I say okay. Okay, so this is it. And so this is the store. That is the STA. Okay, micro instruction. Okay, now let us just see the outline of this program. The program wants you to write an assembly language program to simulate add operation on two user entered numbers. Okay, so what we are doing here is we are reading the first number. Okay, we are adding it to sum, whatever number has been read. Okay, the initial value of sum is 0. Okay, and we are adding it to this number sum. Okay, and then we are storing sum. Whatever is the result of this, it will be stored in AC, and we are storing that back into sum. Okay. Now, let me show you how this works. So I'm going to turn on the debug mode, and I'm going to step by each instruction now. Okay. So the first thing before I start is, let's say, assemble and load. Okay, we have said assemble and load. Okay, and you can see that this sum variable here has been assigned the address 18. Okay, you can see that this is a 2 byte location. Okay, where the sum is stored, and it has been given the value 0 as we had requested. Okay, now let's start with our program. So I say, so please see, we're going to see this program, entire program step by step. I'm using the debugging mode. Okay, I'm stepping by the instructions. So the first instruction was read. So it is asking for an integer. Let me put 3. Okay, so as soon as I put 3, please see the value goes to the AC. You can see that. Okay, this was the job of the read instruction. Next is add sum. So what this had to do was the value of sum so far, you can see that, please see, the value of sum is 0. So it should have added 3 with 0 and put the result back into AC. The result is 3 in the AC. But so far, this result has not been stored in sum. The sum continues to store 0 at the moment. Okay, so that's why we need STA sum next. I'm saying step by instruction. So store sum, you can see that this value 3 is now written at this variable sum, right? And then now what we do is we read the next number and do the same thing. Okay, so we read the next number. Let's say it is 4. And this is, first of all, added to the AC. This will be, now please see, this means what will be done? 4 plus 3 of sum will be added. 7 should come in AC after this instruction, right? So you can see that AC has 7 now. And when I say store sum, till now, sum has the value 3. When I say store sum, the value 7 gets stored into the sum. Okay. Now, since the program wanted us to just read 2 numbers and add 2, we've already done this. Now, what we want to do, we want to simply read whatever is in the sum into the accumulator back. Okay, so we are using the reverse instruction of store now. Okay, store was STA, store accumulator into the variable sum. Now what we're doing is load into AC. So this is LDA. This is the same as, you can see that this is the same as LDA. Load into accumulator whatever a value is there in the sum. So after I execute this, the value 7 will be loaded in the, you can see it will be loaded in the AC, and I'm saying write. So when I say write, whatever is the value of AC will be displayed to the user. So you can see the output 7 has come. Okay, and then I'm saying stop. Okay. Now we've seen all these instructions. Let us, we just need to look at the implementation of the machine instruction LDA, that is load. So let me show you how to make this instruction as well. So again, as usual, we go to the modify menu, we say machine instruction, and here you can see that I'm, I already have this instruction load. So this is again a machine instruction. So the fields will be OPADDR, right? And what are we going to do? Again, as usual, we are transferring the address part into the MAR. And this time what we have to do, we will go to the main memory at this address. Whatever are the transfer contents, we transfer into the data register, and from the data register to the accumulator. Okay, so load whatever is stored at this memory address into the accumulator. Okay, so this is it. So we have covered up to question number 3.